Measurement of length and motion. Minnie is sitting in the classroom with her friends. All the students are talking about the new chapter which the teacher is going to start today, named Measurement. They all are excited. Pinky asks everyone to measure the length and breadth of their teacher's table with the help of their hand spans. Each student measures it one by one and finds slight differences in the measurements. This is due to these small differences in the lengths of their hand spans. Then Anish asks everyone to measure the distance between the teacher's table and their own desks with the help of their footsteps. Everyone counts the footsteps and concludes that it is another method of measurement. Harshita shares that she has seen her grandmother measuring cloth by the length of her arm. These all are old methods of measurement. The children enjoyed measuring lengths using body parts but also realized that a standard unit is required so that the measurements of the same length made by different people do not differ. Measurements are essential for different physical quantities. Measurement. When you buy shoes for yourself, how do you know which size to buy? The shopkeeper measures your foot. Similarly, a carpenter measures the height and width of a cupboard before making its door. The size of the shoe, the height, and the width of a cupboard all involve measurements of the distance between 2 points. The quantities that can be measured are called physical quantities. Length, weight, volume, time, speed, and temperature are some quantities that can be measured. The physical quantity associated with the measurement of distance between 2 points is called length. Therefore, we can say that measurement is the comparison of an unknown quantity with a known fixed quantity called a unit. It determines the number of times a physical quantity is related to its unit. History of measurement. In the past, different body parts were used to measure length. The distance of a step, the width of a finger, angul, the length of the arm, etc. were some of the widely used units of length in the past. Some other body parts used for measuring length and the names of their corresponding units are given as follows. Distance between the tip of the thumb to the tip of the little finger of a stretched open hand is handspan, also known as balisht. Length of foot is a foot. Distance between the end of outstretched arm and chin is a yard. Arm's length from elbow to fingertip is a cubit. Length of a step is a pace. These methods of measuring length were not satisfactory because the length of the arm, foot, and handspan varied from one person to another. Activity 1. Measure the length and breadth of your science book with the help of your left handspan. Now ask 2 of your friends to do the same and note their readings. You will find that all the results might differ. This is because the length of your handspan might be different from the handspans of your friends. In the above activity, the handspan used for measurement is an example of a unit. The length and breadth of a book are expressed in two parts, a number and a unit. For example, if 3 handspans are used to measure the length of book, then 3 is the number and handspans is the unit. Standard units. In the olden days, the length of a body part of the king was taken as the standard to maintain uniformity. Still, it was not enough. Till the 19th century, various countries used their own system of units. As a result, there were many units for the same physical quantity. This was quite confusing as there was no uniformity all over the world. For uniformity and convenience, a common unit is necessary for the measurement of a physical quantity. For accurate measurement, we need a standard representation of each physical quantity. This chosen standard is called a standard unit. A standard unit is a standard measure that has some definite and convenient quantity so that it remains the same under all conditions. In 1960, it was recommended that a common system called the International System of Units or SI unit system should be used all over the world. The SI units of all three fundamental units, length, mass, and time, are given below. Quantity, SI unit, symbol. Length, meter, m. Mass, kilogram, kg. Time, second, s. Nowadays, SI units are followed in almost all countries for all scientific work. However, some other systems of units which are still in use are given below. FPS, foot pound second, CGS, centimeter gram second, MKS, meter kilogram second. The SI unit system is based on the MKS system, in which the unit of length is meter, the unit of mass is kilogram, and the unit of time is second. The SI unit of length is meter. It is denoted by symbol m. 1 meter, m, is divided into 100 equal divisions and each division is called centimeter, cm. Multiples and submultiples of units. The units which are used for measuring larger quantities are called multiples of fundamental units. For example, the distance between two cities will be a very large value if measured in meters. Therefore, kilometer, which is a multiple of the meter, is used and is equal to 1,000 meters. Here, the prefix kilo is used before the unit. Similarly, to measure smaller quantities, submultiples of fundamental units are used. For example, the length of a pencil box can be measured in centimeters, which is a 100th part of a meter, or 100 centimeter equals 1 meter. Here, centi is used as prefix. The fundamental units, their multiples and submultiples can all be interconverted. 10 millimeters equals 1 centimeter, 10 centimeters equals 1 decimeter, 10 decimeters equals 1 meter, 1000 meters equals 1 kilometer. A simple way to remember the conversion table is the mnemonic milli se deci me deca he kilo. When you move from left to right, multiply each by 10. When you move from right to left, divide each by 10. 1 millimeter multiplied 10 equals 1 centimeter. 1 centimeter multiplied 10 equals 1 decimeter. 1 decimeter multiplied 10 equals 1 meter. 1 meter multiplied 10 equals 1 decameter. 1 decameter multiplies 10 equals 1 hectometer. 1 hectometer multiplies 10 equals 1 kilometer. Some prefixes that are used for multiples and submultiples are given in the following table. Prefix, abbreviation, multiple or submultiple. Deci, D, submultiple 1 by 10. Centi, C, submultiple 1 by 100. Milli, M, submultiple 1 by 1000. Kilo, K, multiple 1000. Mega, M, multiple 10 lakh. Giga, G, multiple 100 crores. The commonly used multiple or submultiple of units for measuring length, mass and time are given in the following table. Units of length, units of mass, units of time. 1 meter equals 10 decimeters. 1 kilogram equals 1000 grams. 1 minute equals 60 seconds. 1 meter equals 100 centimeters. 1 gram equals 10 decigrams. 1 meter equals 1000 millimeters. 1 gram equals 100 centigrams. 1 hour equals 60 minutes. 1000 meter equals 1 kilometer. 1 gram equals 1000 milligram. 1 day equals 24 hours. 1 ton equals 1000 kilograms. Advantage of SI system. It is universally accepted, standardized set of units. These units do not change with time. Even very small measurements are possible in this system. Interconversion within the system is simple and hence calculations become easy. Measurement of length. Length is measured as the distance between 2 points or objects. The standard unit for measuring length is meter. The measured value consists of two parts: a numerical value and the unit of measurement used. If the length of a table is 3 meter, it means that the meter length is repeated 3 times. Various scales of measuring length are expressed with symbols km, m, cm and mm respectively. Neither a full stop is used after the symbol nor an s is used for the plural. While writing the length, always leave a space between the number and the unit. Need for accurate measurements. There are many instruments used to measure length like rulers and measuring tapes. The type of instrument to be used depends on the type of work and the accuracy needed. For example, for measuring small lengths in geometry, we use a 15 centimeter scale ruler provided in the geometry box. Therefore, we should select an appropriate measuring instrument that suits our requirement. Measuring tape, which is flexible, is used by a tailor to take measurements like that of our chest, waist, and other body parts. A meter scale is used by cloth merchant. Stiff steel measuring tape is used by masons, carpenters, and civil engineers. We can measure very small lengths by using special instruments like the vernier calipers and the screw gauge. Using meter scale to measure length correctly. It is important that the measurement is done correctly. There are three possible errors which may occur while using a meter scale. Proper placement of scale. If the scale is not placed exactly or correctly along the length being measured, a wrong reading will be obtained. It is therefore necessary that the scale is placed exactly or correctly along the length being measured. Parallax error. An error can occur due to the wrong positioning of the eye while taking the readings. This error is called parallax error. This error can be avoided by placing the object in such a way that the eye is exactly above the point where the measurement is to be taken. In case of damaged zero mark of the scale, the portion of the scale near the zero mark may be worn out. So, in order to measure the length of the object, we usually do not start from zero mark of the scale. In such cases, we should use any other full mark of the scale, and then we must subtract the reading of this full mark from the reading at the initial end. For example, in figure A, the length of the block is 7 minus 1 equals 6 cm. Can you find the length of the block in figure B? It is 9 minus 3 equals 6 cm. Activity 2. Take out a pen, a pencil, an art brush, an eraser, and a sharpener from your geometry box. Measure the length of each item using your plastic scale and write it in the table given. Serial number, name of the object, length of the object. Number 1, pen. Number 2, pencil. Number 3, art brush. Number 4, eraser. Number 5, sharpener. Measuring the length of a curved line using a thread. The process of measuring the length of a curved line using a thread is given in Activity 3. Activity 3. Aim. To measure the length of a curved line. Materials required: a thread and a scale. Procedure. Step 1. Put a knot near one end of the thread. Step 2. Place the knot at the beginning of the line as shown in figure A and press it with your thumb. Step 3. Place a portion of the thread along with the curved line and press it with your forefinger. Step 4. Keeping your finger pressed and move the thread along the curved line. Step 5. Repeat these steps 3 and 4 to trace the entire length of the curved line using the thread. Step 6. When the thread reaches the end of the line, put a mark on it. Step 7. Stretch out the thread on a scale and measure its length as shown in figure B. Observation and conclusion. The length of the given curved line has been measured and it has been found to be dash centimeter. Describing position. On No Tobacco Day, a march was organized by the students with banners near the community hall as part of the awareness program. It was an event in which all students from class 6 to 12 had to participate. Through the PA system, the head of the school announced that all students, along with their class teachers, were supposed to assemble near the school gate to start the march together. Each class was at a different distance from the school gate. Each student covered a different distance to reach the gate. The school gate was their reference point, and from there, all the students covered the same distance in the march. When distance is described with respect to a fixed point or object, that point is called a reference point. Rest and motion. Observe a clock carefully. Note the position of its hour and minute hands. Wait for 5 minutes. Again, note the positions of both. Which of the two seems at the same position? Which of the two has changed its position? If an object does not show any change in its position over time, it is said to be stationary or at rest. Since the clock has not changed its position, it is at rest. It will change its position only if somebody lifts it. If an object changes its position with time, it is said to be moving or in motion. The minute hand changes its position with respect to time. Therefore, it is said to be in motion. Can you name some other objects around you that are stationary? Now flatten up your palm. Place the clock on the palm. Take a few steps in the room. Are you now in motion? What about the clock? The clock remains at the same place on your palm. Is it now at rest or in motion? The clock is at rest with respect to your body, but is in motion with respect to the other objects in the room. Activity 4. Tell the students to observe all the things around them from the start of the day, from home until they return home. Write down 5 things which are in motion and 5 things which are at rest in the table given. Serial number, things in motion, things at rest. Number 1, number 2, number 3, number 4, number 5. Also discuss with your classmates about the state of motion or the state of rest of an object. All the things which change their position with respect to the fixed reference point are called objects in motion. Motion is always observed and measured with respect to a frame of reference. When we walk, we change our position with respect to the floor which is at rest. The fan itself is at rest, whereas its blades are in motion. When you sit in a moving bus, you are at rest with respect to the bus, but are moving with respect to the objects outside. Types of motion. Different objects possess different types of motion. Some objects move in a straight line, whereas some may follow curved paths. The following are the different types of motion. Translatory motion, the motion in which all the parts of an object move through the same distance in a given time, is called translatory motion. For example, a moving car, a ball sliding down a slope, a man walking on the road, etc. Translatory motion is of two types. Linear motion. If an object moves in a straight line, it is said to have a linear motion. An athlete running a 100-meter race, a child going down a slide, or a car moving on a straight road all show a linear motion. Curvilinear motion. If an object moves along a curved path, its motion is called curvilinear. For example, a woman walking on a curved road, a car taking a turn, etc. Circular motion. It is the motion of an object in a circular path around a fixed point called axis. In circular motion, the object reaches the same point from where it starts. For example, the motion of a minute hand of a clock and the motion of a ball tied to a string and whirled around. Rotational motion. When an object undergoes a motion in such a way that its paths cover different distances in a given time, it is said to have rotatory motion. In this motion, the object moves about an axis. The blades of a fan, a spinning top, and a Ferris wheel all have rotatory motion. Random motion. Irregular motion is the motion of an object in which the direction of motion is not fixed and is also called as random motion. Examples of it include movement of a football player on field, flirting of a butterfly, motion of an ant, etc. Oscillatory and vibratory motions. When an object moves to and fro about a fixed point, it is said to be in an oscillatory motion. For example, the motion of pendulum of a clock and motion of a swing. In both cases, objects move to and fro from their mean position. Sometimes the whole object does not show to and fro motion. Such a motion is termed vibratory motion. Example, when string of a guitar is plucked, only the string shows to and fro motion. So it is termed vibratory motion. During this motion, a change in shape and size takes place. All musical instruments show this type of motion. Periodic motion. When the same motion repeats itself after equal intervals of time, we call it a periodic motion. The oscillations of a pendulum, the revolution of the earth around the sun, the movement of hands of a clock, and movement of hands while beating a drum are some examples of periodic motion. Different motions at the same time. Consider the movements of the earth. The earth revolves around the sun in a circular path. So it shows circular motion or revolution. At the same time, the earth also moves on its axis, which is called rotation. So the earth shows two types of motion at the same time, circular and rotational. The earth repeats its motions, revolution and rotation, at fixed intervals of time. So its motion is also termed periodic motion. A spinning top spins on its axis. It also moves in a curved line as a whole. So it shows rotatory as well as curvilinear or circular motion. Similarly, when a person rides a bicycle, the cycle as well as the cyclist show linear motion, translatory motion, but the wheels show rotatory motion as well. When a screw is opened, it shows linear as well as rotatory motion. Uniform and non-uniform motion. Uniform motion. The motion of a particle or an object is said to be uniform if it covers equal distances in equal intervals of time. Look at the given picture. In this, a car is covering equal distances in equal intervals of time. So the car is said to be in uniform motion. Non-uniform motion. The motion of a particle or an object is said to be non-uniform if it covers unequal distances in equal intervals of time. For example, motion of a car on a crowded road and a butterfly moving from one flower to another. Signs in the vicinity. A fathom is the distance between the fingertips of both outstretched arms. Unlike other ants, desert ants don't use pheromone smell trails to navigate between their home and a food source. The pheromones evaporate very quickly in the hot desert. Instead, they use a way to calculate the direct route home. They use sunlight to judge direction. Daylight saving time, DST, or summer time is the practice of advancing clocks during summer months by 1 hour, so the evening daylight lasts an hour longer. This is practiced at many places like Europe, Australia, etc.